Good morning, students. This is Math session 9th standard, chapter 1, set language. In that, we are going to see types of sets. We are classify the types of sets as 11. They are empty set or null set, singleton set, finite set, infinite set, equivalent sets, equal sets, universal set, subset, proper subset, disjoint sets, power set. First one is empty set or null set. A set consisting of no element is called the empty set or null set or void set. It is denoted by pi or empty set. For example, A equal to, here A is the set name, x such that x is an odd integer and divisible by 2. Here odd integer is divisible by 2. There is no odd number divisible by 2. So for that A answer is empty set. Second one is singleton set. A set which has only one element is called a singleton set. For example, S equal to the set of all even prime numbers. Here S is the set name. We are having only one even prime number, that is 2. Third one is finite set. A set with finite number of elements is called a finite set. For example, first one, the set of family members. Definitely for every family we are having finite number of members only, either 2 or 3 or 5 or 10, like that. Second one is the set of all English alphabets. In English alphabets we are having only 26 numbers. So it is called as the finite set. Here we are having one note, that is cardinal number of a set. The number of elements in a set is called the cardinal number of the set. The cardinal number of a set A is denoted by n of A. Fourth one is infinite set. A set which is not finite is called an infinite set. For example, set of all 5, 10, 15, etc. Here 5, 10, 15 are the multiples of 5. It's going on. So it is called as infinite set. See the second example. The set of all points on a line. In a line we are having so many points, that is infinite number of points. So that is also infinite set. Fifth one is equivalent sets. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written as A equivalent to B. If A and B are equivalent sets, then n of A equal to n of B. That is, number of elements in A is equal to number of elements in B. For example, consider A equal to set of all ball, bat. Here 2 elements, and B equal to set of all history, geography. Here 2 subjects. Here A is equivalent to B because n of A equal to n of B equal to 2. Sixth one is equal sets. Two sets are said to be equal if they contain exactly the same elements. Otherwise, they are said to be unequal. In other words, two sets A and B are said to be equal if every element of A is also an element of B and every element of B is also an element of A. For example, consider the sets A equal to set of all 1, 2, 3, 4 and B equal to set of all 4, 2, 3, 1. Here A and B are having same number of elements as well as same elements. Since A and B contain exactly the same elements, so A and B are equal sets. Seventh one is universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. Let us see the example. If A equal to set of all Earth, Mars, Jupiter. Here A is the set contains 3 planets name. So the universal set is all the planets in the solar system. Then the universal set U is the planets of solar system. Eighth one is subset. Let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. We write like this. We read this as A is a subset of B. Let us see this diagram. Here, two sets. One set is A and the big circle is B set. Here, small a is the element of A. Then, small a is also the element of B. That is called as the subset. Thus, A is a subset of B, that is B is the biggest set if A belongs to A, capital letter A, implies small a belongs to capital B, that is represented in this diagram. If A is not a subset of B, we write A is not a subset, that is the symbol along with this cross symbol is B, not a subset of B. Clearly, if A is a subset of B, then n of A is less than or equal to n of B. That is, if A is the subset of B means B is the biggest set, A is the smallest set. For example, write all the subsets of A equal to set up of small letter A, comma B. Here the A, capital A is the set name, small a and small b are the elements of B. Now we are going to write the subsets. Let us see the solution. If A is the set of all small letter A, comma B means the subsets are empty set, then set of all A, set of all B and set of all A, comma B. Ninth one is proper subset. Let A and B be two sets if A is a subset of B and A not equal to B. Then A is called a proper subset of B. We write this as A is a proper subset of B, that is not the line symbol. For example, if A equal to set of all 1, 2, 5 and B equal to set of all 1, 2, 3, 4, 5. Here B is the biggest set, A is the smallest set. These two sets are not equal. So we can say A is a proper subset of B. That is, in symbol we have to write like this. 10th one is disjoint sets. two sets A and B are said to be disjoint if they do not have common elements. In other words, if A intersection B equal to empty, that is pi, then A and B are said to be disjoint sets. That is, for A and B, there is no common element. This is the representation of disjoint sets in Venn diagram. 11th one is power set. The set of all subsets of a set A is called the power set of A. It is denoted by P of A. For example, if A equal to set of all 2, 3, then find the power set of A. That is, A is the set contains two elements, that is 2 and 3. For this, the subsets are empty set, set of 2, set of 3 and set of all 2, 3. Then the power set is set of all subsets. That is, for all this I have to write one set. That is called as the power set of A. Let us see the another example. If A equal to set of all empty and set of empty. Here we are having two numbers. Then the power set of A is set of all empty set 1. Then for this set of empty, then for this set of all set of empty, then for these two elements you have to write one set. Here we are having one important property, that is, if n of A equal to m, that is number of elements in A is m, then number of elements in power set is, that is n of P of A, is represented as 2 power m. The another one is the number of proper subsets of a set A is n of P of A minus 1. That is, in this this null set, I have to represent the remaining as number of proper subsets. So the formula is 2 power m minus 1. Thank you, students.
Thanks for watching my video.